Today, I'm going to show you how to use the React navigation. We will implement a drawer navigator, Tab Navigator, and Stack Navigator to allow the user to navigate within the apps. Welcome back to Just Code China. Please support us by subscribing to our channel and like our video. If you have not watched the last tutorial video, please do so by click on the link provided below. If you have any question in this tutorial, please leave a comment below. Today's tutorial will modify the dictionary app we had created in the last tutorial to illustrate how to use React navigation features. Please visit our GitHub page to download the tutorial to source code. We need to restructure the existing app. Let's take a look on the new structures of the app we are going to create. First, we will create a drawer navigator. A drawer navigator is the slide menu on the left or right of the screen. In the drawer navigator, we have three menu items that links to the profile, home, and about page. Within the home page, we have the Tab Navigator, which consists of two tabs. The first tab links us to the search screen, which allows the user to perform a word definition search. The second tab will link us to the Stack Navigator, which in turn links us to the flavored list and word detail page. You can treat a Stack Navigator as a last in, first out default pipeline. In this example, we have the flavored list page as the first item of the Stack Navigator. When the user clicks on the word in the flavored list, the app will create the word detail page components and push it into the Stack Navigator. If the user presses the back button, the app will pop up the word detail page component out from the Stack Navigator, and the current page will be shown is the flavored list page. Before we start coding, we need to install a few more npm modules required by the application. Let's bring up our terminal screen. Make sure you are in the project folder. The first module we're going to install is the React Navigation native module. Just tap Young, add React Navigation native and press enter. This is the base module for the React navigations. Next, we will install a few modules in one command. Just key in the command as shown. These modules are required by the base module for React navigations. Next, we are going to install the drawer, tab, Stack Navigator module. Key in the command as shown. Now, we need to install the async storage module by keying the command Young add React Native Community async storage and press enter. This module allows us to save data in the device storage. Next, we are going to install the swipe list view. Key in Young add React Native swipe list view and press enter. This module allows us to display data in a list view format. Followed by, we are going to install the vector icon module. Key in Young, add React Native vector icon and press enter. This module allows us to display an icon within the app. The last module we need to install is the moment module. Just key in Young add moment and press enter. This module allows us to perform date formatting with ease. We have completed all the module installation. Next, we are going to perform some configuration for certain modules that we have installed. Let's bring up the VS Code and open the port file under the iOS folder. Add in the port configuration for vector icon as shown and save the file. Now, open the info.plist under the iOS Just Code DICT folder and add in the following lines as shown and save the file. Next, open the build.grader file under the Android app folder. Change the Enable Hummus to True for better performance on Android device. Just below the Enable Hummus block, add in the Apply configuration as shown for the vector icon module. Scroll to the bottom of the file until you see the dependencies block. Add in the 2 lines implementation as shown and save the file. Now, let's switch back to the terminal screen and key in the command to perform a port install for iOS as shown. The port install will install all the required native modules for iOS. Next, we need to clean the Android build files as we had enabled the Hummus engine. Just key in the command as shown and press enter. We had completed all module installation and configuration. Let's try to run the application in iOS Simulator. First, we will start the Metro Bundle manually by keying Young Start Reset Cache. You can let React Native to start the Metro Bundle automatically. However, I prefer to start it manually. After the Metro Bundle load, key in npx React Native Run iOS and press enter in the other terminal tab. The application is running now. Let's bring up VS Code again and we will start to modify the application. First, we create a folder called Screens under the source folder. Within the Screens folder, we will create the favorite detail, profile, and search folder. We will also create the respective index.js file with empty structure under each folder. The favorite index.js will display a list of words the user has favorited. The favorite detail index.js will display the word definition for the selected favorite word. The profile index.js will show the user profile, and the search index.js will allow user to search for a word definition. Next, we will create the header folder under the components folder. Within it, we will create the index.js to display the header in each of the screen. Although React Navigation also can display the header, however, I feel that it is easier to use a customized header. Let's return an empty view for now. We will come back to complete this file later. Now, let us create a common style.js file under the root folder. This file will consolidate all the common styles that used by the application. Let us open the app.js file and move the current style definition to common style.js file. Then, we will move the existing logic and UI in app.js to source, screen, search, index.js file. Let's modify the render method in the app.js to return a dummy view. We are going to integrate React Navigation into the application now. First, let us create a Drawer Navigator by import create Rover Navigator module. Then we define the Rover Navigator object constant variable. Followed by we define a method called Rover NAV to return the navigator definition. Within the Rover Navigator, we create two screen elements that link to the search and profile screen. The name is the menu item name, and the component hold the actual screen component the menu item link to. We also pass in the option to set the title of the menu item. To use the Rover Navigator, we need to modify the app render method. We need to create a navigation container to hold the status bar and the Rover NAV components. Please take note that all navigator components must reside in the navigation container. Let us save the changes and let the simulator reload. On the simulator, we slide the screen from the left to right to bring out the Rover Navigator. The default Rover Navigator doesn't look great, so we are going to customize its appearance. This is done by implementing the Rover Content method. Let us create a method called Rover Content, which takes in the props as its parameter. In this method, we will return the JSX for the Rover Content. In the JSX, we create a header section view and an image element to hold the profile picture. We also define the style for the header and profile image in the common style.js. Below the header view, we will insert the Rover Content Scroll View component to hold all menu items belong to the Rover Navigator. The Rover Content Scroll View allows the user to scroll the menu item if there are too many items that the physical screen can hold. Next, we will insert the Rover item list to populate all the menu items. We will set the background color to transparent and pass in the props parameter. Let's save the file and see the changes in the simulator. We also can add an extra menu item that is not under the Rover Navigator by using the Rover item component. Let's add in the Rover item by giving it a label and launch the browser to a website when the user clicks on it. We need to import the linking from React Native module. Let's save the file again and see the changes in the simulator. Next, we are going to create the Tab Navigator. Similar to the Rover Navigator, we start by importing the Create Button Tab Navigator module. Then, we define Tab Navigation Object Constant variable. Followed by, we define a method called Tab Nav to return the navigator definition. At the return JSX, we create the Tab Navigator element. And within the element, we create two tab screen elements and link to the search and favorite screen component. To use the Tab Navigator in the app, we will nest the Tab Navigator in the Rover Navigator object by changing the first screen in the Rover NAV from Search to Tab NAV. Let's save the file and see the changes in the simulator. We can now change the screen from search to favorite by tapping the Tab Navigator. As usual, the default Tab Navigator doesn't look great. We are going to customize its appearance by adding icon and change the color. To add an icon in the Tab Navigator, we first import the icon module. Then, we need to implement the tab bar icon method in the Screen Options attribute at the Tab Navigator. In the tab bar icon method, we return the icon JSX based on the route name to determine which icon image to use. To change the color and height of the tab bar, we just specify the option and style in the tab bar options attribute at the Tab Navigator. Save the app.js file again and let us take a look at the changes at the simulator. We have completed both the drawer and Tab Navigator implementation. Before we go to create the Tab Navigator, we need to modify the word definition component to allow user to add a word into the flavor list. Let's open up both the word definition index.js and library helper.js file. In the helper.js file, let us create a few helper methods to manage the favorite list. The first method is the isFavorite. This method detects if a current word is in the favorite list or not. It reads the favorite list from the async storage by the name myFavorite. If the result is valid, then it will convert the result from string to JSON object. It then filters the list with the word passed in via the parameter. If the filtered list contains any element, this means that the selected word is in the favorite list. The next method is the makeFavorite. This method will add a word into the favorite list. It first creates a new list with the selected word in the first item. It then reads the existing favorite list, if any, and append it into the favorite list. Next, we will convert the favorite list back to string and save it back to the async storage. Followed by is the deleteFavorite method. This method first reads the existing favorite list from the async storage. Then, it will filter the favorite list to check if the word exists. If exists, it will get the index of the word in the list and remove it from the favorite list and save the favorite list back to the storage again. The last part of the deleteFavorite method is called the callback function. If it is defined, the callback function allows the caller components to know that the operation is completed so that the caller can update the UI if required. Next is the getFavoriteList method. As the name suggests, this method returns a list of the word the user has favorited. It first reads the list from the storage. If the list exists and the user has specified a search keyword, then it will return a filter list. Else, it will return the entire list. The last method to be added in the helper.js is the getSense method. This method will return the first sense in the word definition written by the Oxford Dictionary API. It first checks if the lexical entry exists in the definition object or not. It will loop through the entries and try to get the sense if it exists. If the sense exists, then it will get the definition. If the definition length is more than 0, then it will break the loop and return the result to the caller. Back to the word definition index.js file, we will add an icon to allow the user to favorite a word he or she searched for. First, let's import the icon modules. Then, we add new properties called hideFavorite in the word definition function. It is used to decide to display the icon or not. We also need to add a new state and setter to keep track if the word is being favored or not. Followed by, we will update the existing favored state with the result returned by the isFavoredHelper function. We call the setIsFavored method to update the favored state returned by the isFavored method. Now, in the JSX, let's add the new icon after the speaker icons. We will check the hide favorite props before displaying the view that hold the favorite icon. In the view, we surround the icon element with touchable opacity to allow user to tap on the icon. When the user tap on the icon, the onPress method will call the helper.makeFavored methods to add the word into the favored list and update the states if it is not in the list yet. Or it will call the helper delete_favored method and remove it from the favored list and update the state if it is already in the list. If the isFavored state is true, then we will display a red solid heart icon, else we will display a gray empty heart icon. Let's save the changes and test it on the simulator. In the simulator, we will key in awesome in the text box and tap on the search button. Now, we can see the empty heart icon on the right of the screen. Let us tap on the heart icon and it will change to a solid red icon. We have completed the changes of word definition index.js file, and the word awesome has been added into the favored list. Now, we are going to modify the favored index.js file. Let's take a look on the new app structure diagram again. The second tab in the Tab Nav component is linked to a Tab Navigator. So now we need to create the Tab Navigator in the favored index.js file. First, let's import the required modules from React Navigation. Next, we will create a functional component at the end of the file to replace the export default favorite. This functional component will return the Tab Navigator with two screens. The first screen will link to the favorite component, and the second screen will link to the favorite detail component. We make use of the useIsFocus hook to get the isFocus state and pass it into the favorite screen component. We have completed the Tab Navigator creation. Now, we need to modify the favorite component to show a list of user favorite words. Let's import the swipe list view and the rest of the required modules. Next, we will create a constructor and initialize the super and state. Followed by, we create a component mount empty method first. Then, we create a method named loadFavoriteList. In it, we will call the helper.getFavoriteList method to load the user favorite word from the device storage and place it in the state. Next, we create the componentDidUpdate method, which takes in the previous props as parameter. What this method does is to check if the favorite screen component is selected in the Tab Nav component. If the previous prop isFocus is false and the current prop's isFocus is true, this means that the user has just selected the tab that link to the favorite component. In this case, we will reload the favorite list again. The componentDidUpdate ensures the favorite component will always refresh the favorite list whenever the second tab in the Tab Nav is selected. With the data available in the state, we now can create the UI to display the favorite list. In the render method, we add in the swipe list view component. Within the swipe list view, we assign the data to the favorite list state. Then, we specify the key extractor method to return the word as the key. Do take note that each row in the swipe list view consists of two layers, the front layer and the back or hidden layer. User can select the front layer, left or right to reveal the hidden layer. Now, let's implement the render item method in swipe list view to populate the front layer for each row. We first create the touchable highlight to encapsulate all the child's view. We need to specify the key for touchable highlight so that React Native will be able to identify each row. Then we specify the underlay color, which will be shown when the user taps on the row. Next, we will implement the onPress method to navigate to the favorite detail screen when the user taps on the row. We will use the navigate method to perform the navigation by passing the name of the navigation screen and the parameters that hold the words to be displayed. Followed by, we will create a child view for the touchable highlight to show the word, date, and sense for the favorite word. On the right side of each row, we will display an arrow. Now, let's implement the render hidden item method in swipe list view to populate the hidden layer. We will create a view to hold the touchable opacity component. Within the touchable opacity, we will have a trash bin icon. On the touchable opacity onPress method, we call the helper delete favorite to remove the selected word from the favorite list when the user taps on trash bin icon. Next, let's implement this empty component method in swipe list view to show a message when there is no word in the favorite list. The message will only show when the list is loaded but is empty. We will set the left open value to 0 so that user cannot swipe the row to the right. We then set the right open value to -50 so that when user swipe the row to the left, it will open 50 pixels on the right. Just below the closing of save area element, we will display the loading view if the app is still loading the favorite list from the storage. Let's complete the favorite screen component by defining all the style required by the JSX element. We will not go into detail of the style definition. Now, let's save the file and see the result in the simulator. We can see the favorite component will display a list of favorite words the user have added. Let's tap on the word in the list and the Tab Navigator will navigate to the favorite detail screen. Next, we need to modify the favorite detail screen to show the word definition. We start by import the required modules. We import the useRoute hook so that we can get the route object to retrieve the parameter passed by the favorite screen component. Scroll to the bottom of the file and replace the export default favorite detail with a functional component. In this function, we will use navigation and use route hook to get the navigation and route state and pass it to the favorite detail screen component. The route state will contain the word parameter passed by a favorite screen component. In the favorite detail component, we create the constructor to initialize the state. Then, we create the component mount method to get the word definition by passing the selected word in the route parameter to the getDefinition method. Now, we will create the async getDefinition method to get the word definition from Oxford API. We first set the loading state to true to indicate the app is loading the definition. If the word length is greater than 0, we will call the API.getDefinition to retrieve the definition from Oxford API. If success, then we will set the definition to the state. Else, we will set the error into the state. Now, we need to modify the render method to display the word definition. First, we display the error message, if any. Then, we will call the word definition component to display the word definition. We will also display the loading screen after the Save Area View element. Save the file and see the changes in the simulator. Let's tap on the favorite tab and the app will display a list of favorite words. Now, tap on the word in the list and the app will navigate to the favorite details screen and show the word definition. The last thing we need to do is to add in the customized header to all the screen components. Let us first modify the header index.js file. At the beginning of the function, we will add in the property to be passed by the caller component, and they are the navigation, left button, right button, title, and its attribute property. Next, we create a view to hold the left button component if defined. If left button component is not defined, then we will create a touchable opacity component to handle the user activity when the user taps on the left button of the header. It will either open a drawer navigator or navigate to the previous screen, depending on the state of the navigation object or its attribute property. Within the touchable opacity component, it will show an icon with either the menu or back arrow image, depending on the state of the navigation object or its attribute property. Next, we will display the title of the header. If the title property is of a string type, then we will encapsulate it with the string with the text element to display it. If the title property is a component that returns a JSX, then we will display the component itself. Next, we will create a view to display the right button component if it is defined. Currently in this tutorial, we didn't use the right button. Followed by, we will set the plot types for the header component. We will define the navigation as an object, title as object or string, left button and right button as object and its attribute as boolean. Followed by, we will define the default value for the property. We will set the title to empty string and both left button and right button to null and set its attribute to false. Last, we will define the style required by the header component. Let's save the files and let the simulator to reload the app. Now, we can see the header appear at each screen with the title and a left button. The left button will depend on the navigation state to decide it should show a menu button or a back arrow button. We have completed the app development for this tutorial. I appreciate your time and efforts, and I hope that you have learned from this tutorial. If you have any question regarding this tutorial, please feel free to leave a comment below. You can follow the link to get a workable source code for the app in this tutorial on our GitHub page. Don't forget to change the Oxford's API app ID and key to yours if you are getting the source code. If you like our video and want to learn more about mobile app developments, do support us by like our video, click on the subscribe button and the notification bell. Thanks for watching. Bye.